Stan Gibilisco here from the Black Hills, getting more black and less white as the weather gets up into the 40-degree Fahrenheit range. Regular heat wave here. Spring can only be a little while away. I'd like to talk about the concept of an electrical ground. A reader seems to be very interested, a reader and a viewer seems to be very interested in this concept and what actually happens with electricity. And in fact, I have two readers that are interested in that business. And I guess it's really gotten to a point now where I might want to start thinking about writing a book like The Zen of Electricity. Something like that. Of course, that may sound a little bit cliche, but let's go back and look at the basic circuit comprising a battery, some sort of a load. Now, when we talk about a load, we talk about whatever it is that the battery is providing power to. For example, an electric light bulb, a motor, a radio, a computer, anything. Here's your battery. So this is a DC circuit. Remember, the minus terminal is that shorter line and the plus terminal is that longer line. So the battery provides a certain voltage, and that voltage is E, and the reason we call that voltage E is because of it stands for electromotive force. That is a sort of like the force that makes a water go through a hose, except that's hydro force, I guess, hydraulic force. The load has a resistance that we denote as R, voltage E in volts, R, resistance in ohms, and then a certain current flows, and I will talk about electron current because it's more intuitive. And they call that current I. That's the mathematical symbol for current in amperes or current in any units, I. And to tell you the truth, I don't have a clue as to where that I comes from. I have no idea. So that's the answer to the question you might have wanted to ask me there. The current in amperes equals the voltage in volts divided by the resistance in ohms. So if you reduce the resistance, you increase the current if you keep the voltage constant. Now, when you talk about where you're going to ground this circuit, well, you don't necessarily need to ground a DC circuit like this at all, particularly if it's a low voltage circuit. But if it's a high voltage circuit that is greater than about 12 volts, any voltage that poses the risk of an electric shock, any risk, you're going to want to ground that circuit. You generally will either ground the negative or the positive terminal of the battery. Let's just suppose that we ground the negative side. Now, when I say ground, that can be an actual connection to the earth, like a ground rod pounded into the earth, or in the case of a vehicle, a boat, an aircraft or something, the large massive metal that makes up the chassis or frame of that vehicle. And here in the United States, that's almost always the negative terminal of the battery and the electrical system. Now, when you talk about this ground, your current flows out of the negative terminal, and it has to have a return path that is back into the positive terminal. If you ground, and I guess I should put that in quotes, if you ground the negative terminal of your battery to your vehicle frame, say, you're not going to really get any current flowing in and out of that ground. The only reason that you want to ground that is as a reference voltage, so you can call this voltage here at the ground, you can call it 0 volts with respect to ground. So you have a reference point with which to measure voltage. So the negative terminal of your battery would be at 0 volts relative to ground. In the case of an automotive battery, you're going to have 12.6 volts nominally. Or when your alternator's running, something more on the order of 13.8 volts. And that is going to be your voltage here at the positive terminal. Now at intermediate points in the load or in the circuits that make up the load, you may have voltages that range anywhere from 0 volts with respect to ground or reference point to the maximum voltage that the electrical system can provide at the time. So when you talk about a ground in that sense, and I'm talking about a vehicle ground now, not any other type of ground like an earth ground, but even if you were to ground the frame of your vehicle or to connect the frame of your vehicle to a ground rod driven into the earth so that it really was a ground, you're not really going to you're not going to get any current flowing in and out of there to the circuit here. The current has to have a return path in order to flow. Now, that said, in large electrical systems, such as the type that you might have in the electric utility, say the power plant that provides your home AC electricity, your home is going to have a ground somewhere. Here's your house. Here's the surface of the earth. Here's your electrical wires coming into your house. And one of these wires is going to go to a ground rod driven into the earth, so that any point that is connected to that ground rod will have a 0 voltage on it. You hope. But suppose that you ground or you connect another ground rod out here somewhere. And you have, say, I don't know, a little office, a little ham radio shack or something, and you pound a ground rod in there. And suppose that you're not actually operating anything. You don't have any electric utility connected up to that. So you have a ground here that's with a different ground rod here. We can't be sure. In fact, we can be pretty sure that these two ground rods are not going to have a 0 voltage with respect to each other. And there's a lot of reasons for that, but mainly it's because currents are constantly flowing in the earth in ways and directions that I can't even tell you where they might go. But or you might have a water system in here that's grounded. You might have running water, but you might have this entirely powered off of batteries. If you touch this ground and that ground, if you connect them together, you might very well want to connect them together with a wire. But when you're doing that, if you're going to connect them together, make sure that you connect them without touching one with one hand and the other with the other. Because, and I'll conclude with this little paradoxical statement that ought to make you ask more questions. I'd never want to answer something and leave you just completely with closure, you know. I want to have you wondering about something. Here is a saying that as a ham radio operator, I've learned this. Believe me, I have. Never touch two grounds at the same time. If you want to find out why, don't say that I told you to try it. Do not try it if you want to live very long. Stan Gibalisco, ham radio operator W1, good vibrations. Vibrations having nothing to do with electricity, or do they? Radio frequency electricity, RF. W1GV is my call sign. Signing off from the Black Hills of South Dakota, 73, which means best regards. Until next time, so long.